All right, so introduction to data management planning. I always start out a little bit by just saying, why do we care about having a plan? What is the importance of this? Ultimately, if we're doing any research in any field that involves collecting data, we ought to have a plan from the beginning for how we are going to describe, collect, store, and potentially share that data. Having a plan in place ensures greater accuracy in our data collection. It improves the efficiency of our data collection processes, and it can improve the security of what we're doing because we've thought through in advance all of the risks and how we're going to mitigate them. It can increase the longevity of our data so that it may continue to be useful to researchers going into the future. And it can make our data more reproducible as well because people have access to information about how we collected what we collected. In some cases, we may also face funder requirements. So this is becoming increasingly common for federal funding agencies to require that funding applications include a robust data management plan. So whether it's required or not, we've got some good reasons for wanting to have a plan in place. All of our plans should be built on the foundation of some data ethics principles. I'm not going to go into a lot of depth on these, but just sort of touching on this idea. Really at the core of this is just the idea that we should do no harm when we're collecting data. So particularly when we're collecting data about people, we want to ensure that we're thinking about the stakeholders, thinking about the participants, and ensuring that we're not causing any damage or creating any harm in the type of data we're collecting or the way that we're handling it. There's several sets of principles that can be useful in thinking about how we handle our data. The FAIR principles set some expectations for how our data should be collected and documented, how people should know that it exists, and if we are able to share some or all of it, how that should be shared. And essentially, we want to be ensuring that our data is findable, accessible, interoperable, and reusable. That's our 4 letters in FAIR. Even if we are unable to actually share a complete data set, we want to be able to make people aware that the data exists and to understand exactly what it includes so that if it were appropriate, someone would know to reach out to us and to possibly request that data. The CARE principles are another kind of good set of core ethics to be aware of. These set expectations for data governance by Indigenous peoples. So if our research is in some way involving or impacting Indigenous peoples, we want to ensure that they share collective benefit from those activities, that they have an authority to control data about them or that impacts them, and then that our data is handled with responsibility and ethics. I've also linked to some other tribal engagement guidelines and tribal consultation policies. If this is something that your research might touch on, you could dig into that in a little more depth. And I've got a link here to dive in a little bit further if you want to read more about how to implement some of these data ethics principles like FAIR in particular. So when we set out to write a plan about what data we're going to collect, how we're going to collect it, there's kind of 5 core questions that we want to be sure our plan is answering. We want to be able to describe what type of data we'll produce, how it's going to be organized, and what kinds of standards we might use for documentation and metadata. And we'll go through all of these in detail in a moment. We want to be sure we describe what steps will be taken to protect privacy, security, confidentiality, intellectual property, if that applies. If we will allow others to reuse any portion of our data, the plan should address how, where, and when that would occur, how access would occur. And then we want to discuss where our data would be archived and preserved and for how long. So in many cases, these kinds of questions take the form of these core sections of a plan. Specific funders will have their own recommended structures for how they want to see a plan written, and we'll touch on that a little bit later. But this is just sort of a good generic list of sections if you don't have a specific funder template to follow. These are the kinds of sections that we'll discuss today. If you are the only researcher, it will be pretty obvious that you're responsible for all of the tasks or duties that you lay out in this plan. If you are working as part of a research team, we want to be sure that as we describe any actions that will be taken in each of these sections, that we identify who on the team is going to be responsible for making sure that we follow the plan. All right, so I'm going to go through this kind of section by section, and we'll talk a little bit about what kinds of questions we want to answer, what that might look like. And then we're going to take some short breaks, just like 1 to 2 minutes for each section, so that you can think about a project that you're working on or that you want to work on, and maybe jot down some notes about what your research would look like in this section, how this would apply to the kind of work that you do. So we're starting out with the data description. The base question here really is, what data will be collected? What is this going to look like at the 30,000 foot level? So this might be just saying, hey, I'm going to end up with one Excel spreadsheet of measurements that I'm taking. I may have 10 interview transcripts in Google Docs, or I may have a folder of 100 functional MRI images and an accompanying table of the demographics of the patients who received those MRIs. We want to be able to indicate what the scope and the scale of the data is. So on some level, this is giving us a sense of size. How big and broad of a data set is this going to be? So we may need to talk about the number of files that will be generated, or within a spreadsheet or a database, we may want to be able to describe the number of rows or records that we anticipate having in that spreadsheet. This may be an estimate at the planning stage, but we hope we can at least ballpark how vast or focused this data will be. We might talk too here about the chronological or geographical scope of the data, if that's relevant to our project. And we might address the level of data that we're planning on, levels that could be multiple that we're planning on collecting. So this might be the raw data, and then another step where we've de-identified it so it's not personally identifying, and then maybe some other levels where we've aggregated together individual data and summarize that data. So it may be that we can't share our raw data, but maybe we're willing to share a summarized level of data. So it's good for us to kind of know what's going to be applicable to what we're producing. Our data description should also describe who we expect the audience for this data to be. Even if you're not planning to share the data set itself, if you're going to write up your findings from analyzing this data set, who's the audience for that? Understanding this upfront is really, really crucial, because this might affect specific variables that we decide to collect as part of our data, so that they are recognizable and reusable for people in that audience community. It may also describe how we format and describe our data. So we really want to make sure upfront that we understand who is the audience that we're speaking to, that this data needs to be relevant for. And then another good question in this section is, are there other existing data sets that are relevant to what we are collecting? And again, this may help us decide specific data points that we're going to collect. So if I'm collecting data on water pollution in Houston, and there's other data sets that might be related to mine, are there certain data points where I maybe want to collect my data in the same units as them, or collect comparable data points so that we can perform comparison between these two related studies? So this also may impact where we think about archiving our data afterwards. If we know there's a lot of other existing data in this subject, my data would be most useful if it's co-located with all of that. So it's good for us to know in advance what else is out there that might be related, and how is it collected. So I want to pause here and just take like about 2 minutes for you to give some thought to these questions, jot down some notes about what this might look like for your research. And we'll come back in about 2 minutes. About another 30 seconds. All right. So hopefully you were at least able to start getting a few thoughts jotted down for that section. The second section we're going to look at here is formats. So kind of the foundational question here is, what formats, file formats, will you use for submitting, distributing, and preserving your data? And the key thing we want to focus on is this idea of preservation, the longevity of our data. This might be somebody else looking at it in future years, but it also might simply be future us looking back at our own data in 5 or 10 years. We want to ensure that we're using platform independent and non-proprietary file formats to the greatest extent possible, realizing that sometimes we may have certain restrictions. But we know software versions change constantly. And if we let too much time go by and we try to open an old file in a program like Microsoft Word, it may not be compatible anymore. Strange things may happen to our data. So some examples here, if we're saving tabular data like a spreadsheet, instead of saving that in an Excel format for preservation, we may want to export it to .csv, which is a much more simplified, non-proprietary file format for saving that data. We want to use text files rather than Word for text documents, and then something like MP4 for videos instead of something like QuickTime that's more tied to a proprietary software. Okay. Figure you can take just a few seconds here if you want to jot down any notes about file formats for your project. I figure this step may not take as long, but. All right, the next section we're going to talk about is metadata, and this one's really should be metadata and documentation, but this one's a bit more in depth. So we'll go through several slides on this one. The main question that we want to answer in this section is, what information would be needed for our data to be read and interpreted in the future? So saving it in a good file format for longevity, that's one important step to make sure someone can even open the file. But how do we know, can we ensure that people can actually look at my spreadsheet? Are they going to understand what my column headings mean when I've labeled all the columns in my spreadsheet? If I have used codes to code any kind of data, are they going to understand what my codes mean? Are they going to be able to understand how I've defined all the things that I've collected? So this is a very, very important step to think about with our planning. Just at the bare minimum, the absolute minimum that we ought to think about documenting is the basic details that would help a user know that this data exists at all and have some sense of where it is or how to ask for it. So at a bare minimum, we want to think about the title of the data set or the project, when it was created, who created it or contributed to it, and whether there are any particular conditions for accessing it. So would you share this data with anybody who emailed you and said, hey, can I see your data? Or would it require that people meet certain criteria? Or is there a confidentiality level that says you really can't share it with anybody? But thinking through what those conditions of access might be. So that's at a bare minimum we want to document. What is recommended is then to go one step beyond that and provide a little bit more documentation. This would include defining our variables. So defining all those data points that we've collected, defining any sorts of standardized vocabularies that we might have used, which we'll talk about more in just a moment, clarifying the units of measurement that we've used in certain fields, defining, again, any codes that we've applied for coding our data, and then documenting the format, file type kinds of questions for the files that are storing the data. There's also sort of an optional level that you could go beyond this if you choose to. At this third level, you would go more in depth to actually document the methods that were used to collect your data. So kind of documenting your steps or your protocols, any kind of analytical or procedural information that you think would be informative for someone else looking at this data in the future, and kind of documenting any assumptions that might underlie the way we went about collecting or organizing this data. So when we think about tackling this first kind of minimum step of just describing the data set itself, we want to know what sort of metadata standards we're going to use. And I realize this is one of those pieces that may be unfamiliar to people who don't work in libraries. We talk about metadata a lot. One good metadata standard that you can consider if you don't have another one in mind is called Dublin Core. This is a very, very basic, easy to understand metadata standard, and it's kind of domain agnostic, so it can be used across lots of different fields. This is sort of the set of fields that Dublin Core defines. So as you're documenting a description of your data set, you would use this to say, okay, I need to give it a title. I'm going to document the creator. I'm going to give it some subject terms to describe what the data is about. So this is going to recommend what kinds of details about your data set you want to document and how they would define each of these. And I've also got a screenshot here of an example. So this is an example of Dublin Core data for a data set of the US congressional roll call voting records. And so it's got the DC stands for Dublin Core. So the DC title, there's the data set title. The creator, it was created by the Inter-University Consortium for Political and Social Research and Congressional Quarterly. There's an identifier with the DOI where you could find the data. So this is kind of what we mean when we're talking about these metadata standards, is just using a standardized list of what details to provide about the data set itself. Dublin Core is a really good basic one, but there are other options that may be more standard in different disciplines. And so I've linked here to the RDA Metadata Standards Catalog, and you could look at their listings of other metadata standards that are common in different disciplines if you wanted to look for another alternative. So now when we get to that, so that's kind of that minimum level of just at least giving people description of the data set and the fact that it exists. If we get to that next level where we want to document the definitions of our variables and our codes and things like this, this is kind of this next step of how are we going to capture that kind of documentation. So the first piece we want to consider here is creating a data dictionary. This really is just sort of a table where you define every variable that you're going to collect. So these would be like each column in your spreadsheet, if you want to think about it like that. You indicate the name of that column, the definition of what the data is that you're collecting there, what is this variable, and then any sorts of rules that someone would need to know about saying this measurement is done in ounces, or this field needs to be a date and it needs to be formatted as year, month, day. So kind of any of those rules that indicate what the data is, how it should be formatted, or if there are a specific limited choice of answers for that field. So this screenshot kind of shows an example of what a data dictionary might look like for a project where they have these different variables, like their group number, their age in years, their date of birth, the variable name, that's like the shorthand they would have at the head of the column. They have the measurement unit, any sorts of allowed values, and then kind of a lengthier description of telling you exactly what that information ought to entail. We also want to think about creating a code book if our data involves any codes. This could be coding on a quantitative side or qualitative coding, either one. Anytime that we're using shorthand codes in our data, we want to have something that defines, here is the code and here is what on earth it actually means. And so I've got an example here. This is from the Carnegie classification. This is what classifies universities as being R1, R2, that kind of thing. they have a field for their basic classification of university, and it uses a numerical code between 0 and 33. So if you go look at their spreadsheet about each university, all you're really going to find there is that numeric code from 0 to 33. But if that's the only thing you look at, you wouldn't know what those numbers mean. What does it mean that a university is an 8? And so you would go to this section in the code book to determine what that numeric code actually translates to in meaningful information. So if we're using any sorts of codes like that, we want to be sure we're providing a guide to what those mean. And then the third item here is creating a README style text file. And I've got a screenshot of this as well. This is just a very plain text file that goes through and provides foundational information. If you were using a metadata standard like Dublin Core, you might put some of that in your README, but a lot of times this is really focused on being very plain English. So if someone finds your spreadsheet saved somewhere and there's a README saved right next to it, the idea is that you open that README first, and it's going to tell you, here is what this spreadsheet is. Here's what's in it, when it was collected, who created it. So giving a little bit of that attribution and context to the data file. And I've linked to a couple of resources here with some guidance on creating those README text files. Those are a really good basic way of documenting your data set. All right, a little bit more I wanted to touch on here with metadata. I want to talk about common data elements and vocabularies. So what are common data elements? Essentially, these are very standardized versions of questions and answer sets that can be used systematically across different studies so that there's consistency in how these questions are worded and what answer choices there are. Now, these exist for lots and lots of different topics, but the example that I will give you to explain it is if we think of a question like gender identity that might show up on a lot of surveys. Those questions can be phrased in a lot of different ways. And then what kinds of choices the survey provides for the participant can vary significantly as to whether they give you a set list of bullet points or all the way just to an open text box where they ask you to free text your self-identification. But if every study is approaching this question in radically different ways, it can make it much more difficult to compare the data that we're getting to find that common ground. So if we go and find a common data element for gender identity, we can kind of ensure that, okay, I'm following some sort of a recommended best practice for how to phrase this question and how to phrase the answer choices. Sometimes if we're just questioning ourselves about exactly how should I structure this question, this can give us something to lean on. If we're working in a team and we're having some debate about how to structure this question, this can give us some form of a justification for making a choice. And then it really can help to ensure more ability to compare among studies. The common data elements do come out of the NIH, the National Institutes of Health. So the questions that are there some of them are more geared towards the health field, but some of them, again, are just going to be very generic kinds of demographic questions that could still be very helpful in a lot of other fields. Standardized vocabulary is the other piece I wanted to touch on here. We want to consider using standardized vocabulary where it is appropriate. Again, health provides us a good example here. There's a vocabulary called the medical subject headings, or MESH, and they define standardized ways of describing medical conditions or aspects of health to make sure that everyone who's going to describe this subject is going to do it in the same standardized language. So if we have a multiple choice question in a survey or something else, or in our data entry tool, where we want a certain concept to always be entered the same way and represented the same way, relying on a standardized vocabulary can really help to ensure not only that we're consistent within our own data set, but that our data set is speaking the same language as other data in our field. So I used MESH as an example within health, but there are lots of other disciplinary vocabularies I included just a couple examples here from art and architecture and from UNESCO that's got some good educational and cultural vocabulary. And then there are a lot more that you can find linked at these other resources. Now, this really does depend on what data points you're collecting. Your variables may not lend themselves to needing standardized vocabulary, but when it's appropriate, it gives us a way of, it's almost like tagging, making sure that we're using the same tag on everything so that people can identify the same concept. Okay, so I know there was a whole lot there in that metadata section, but I want us to take just sort of a couple of minutes to think about what kind of documentation and metadata might apply to your research, particularly thinking about whether it would be appropriate for you to create a data dictionary, a code book, some of these types of things. I'm going to give you a couple minutes to think and jot down some notes. About another 30 seconds. All right. Go ahead and move on to ethics, privacy, and confidentiality. So in this section, part of what we're asking would really relate mostly to human subject research. We want to be thinking about how informed consent is handled and how privacy is protected. So if we have people involved in our research, we want to be sure that we're taking a little time to evaluate the sensitivity of the data, determine whether it contains any direct or indirect identifiers that might be able to identify an individual person, even if we think we've taken out their names and their social security numbers. Are there other factors there that could be combined to identify them? If we have private information, we can do our best to anonymize it to make sure that we're attempting to protect privacy. If we are going to share any level of our data, if we're thinking in advance, and this is why it's so important to think about all this at the planning stage, if we're thinking that we may want to share some component of our de-identified results, we want to think about putting that in our informed consent agreement at the beginning so that the participants are aware that their de-identified data may be shared. I've also linked to another resource here on protecting sensitive data in academic research that is really useful if you want to dive into more detail on this one. But this may or may not apply to a lot of research areas if you're not directly gathering private sensitive information. Okay, intellectual property. So there's sort of two sides to this in terms of the data you're gathering and then the data set you're creating as its own thing. Are there any copyrighted materials that you're using in your data collection? So if I'm just collecting original measurements of something, I don't have to worry. I'm not using anybody else's copyrighted material. But if I'm maybe analyzing literature or something, analyzing someone's speeches, analyzing anything like that that could be published or otherwise subject to copyright or intellectual property, I want to make sure I understand going in. Do I need to get some sort of permission for my use, or do I think it qualifies as fair use that maybe I don't need permission? Even if I've obtained it, then do I think I can disseminate that data? Am I going to need some sort of permission to include that copyrighted material if I share my data? This may also come into play if we're using a like an instrument, some kind of an assessment or a tool that's been copyrighted by someone else. We may get their permission to use that tool in our study, but we may not have permission to republish that tool with our article. So we need to kind of think through those pieces. If we have permissions to use it, maybe to disseminate it in a publication, would those rights transfer to any other steps we may take down the line to share the data or to archive the data in some format? So that's the side of what's coming into our data set. Do we need to worry about intellectual property? But then we also want to think about intellectual property of what's coming out of our study, of what we're producing. Who will own the rights to the data and information produced by your project? Part of this is really understanding the institutional policies, because different universities and research institutions can have very different policies about individual versus institutional copyright control. So even if maybe you're new to SAM and you knew your policy at your last university, it could be very different here. So we always want to ask those questions. I will let you know there are some new policies about intellectual property and data that are in process right now, coming out from ORSP here at SAM. So I don't know all the details yet about what that's going to look like when they finalize these new policies. I understand they're trying to protect the university's opportunity to monetize things that they think could be profitable from our research. But we'll need to take into account how that might affect things that we produce and want to share. It is important to recognize in the USA, just the raw data itself, the fact that I made a list of facts essentially, is not copyrightable. So I have a spreadsheet with a bunch of numbers in it. I can't necessarily copyright that. But specific expressions of our data, specific ways of visualizing it, for instance, might be copyrightable. So if I create a very particular kind of chart that visualizes my data in a certain unique way, that piece might be copyrightable. So we kind of have to distinguish those pieces of just sort of straight facts versus a unique expression of those facts. When we are dealing with putting data out, there's kind of the copyright question, but then even something that's not copyrightable, you can license things in a certain way that can exercise control over how someone else could use it. So maybe instead of just sharing your data openly on the web, maybe you share a description of it and you indicate that it is available to be licensed, and thus you would share it with someone when they sign a license with you, and that license would indicate the exact terms of the agreement between you about how they are allowed to reuse your data, any sorts of requirements about attributing you, that kind of thing, that can help to control any downstream use of that data that you may be concerned about. If you have data that's not necessarily confidential or sensitive, that you're not so much worried about protecting, if you really are interested in just sharing and promoting unlimited use of your data, you have options to license it more openly instead of more restrictively. So you could make your data available under a CC0 license, which essentially says that you remove all restrictions. You don't care about retaining any exclusive rights to it. Anybody can do whatever they want with it. Or you can put other kinds of Creative Commons licenses on it with selective restrictions. So you could say, hey, you can do whatever you like with my data as long as you give me credit for creating it and as long as you don't profit off of it in a commercial use, things like that. So those are some good options to consider if you are interested in sharing your data and making it more widely accessible. So I'm going to give you just about 1 minute here to kind of think about this and jot down any notes about how intellectual property might affect your data coming in or going out. All right, I'm going to move forward to our last couple of sections here. I'm trying to be mindful of our time. So the next section is thinking about storage and backup of our data. Probably all of us have had at least one horrible experience in life where we lost something we really didn't want to lose. So we want to plan in advance where and how are we going to be storing our data to ensure that it stays safe, to ensure that we don't lose things. Obviously, keeping multiple copies, backups, that kind of thing is recommended. So if we think about a storage location, someplace like an SHSU networked drive or cloud storage with Office 365, something like that where there's frequent automatic backups being done, we probably want to think about something like that as being preferable to a USB drive where I've got one copy and I might lose it or drop it and step on it on accident and crush it. We want to think about how we're going to be managing our data during the project. So this can include things like version control and file naming. Now, if you are storing your files someplace like Microsoft Office 365, it provides some default versioning where you can actually go in and look at the version history of a file and hopefully be able to roll it back if you make some mistake or lose something. But you may still also want your own system for downloading backups on a set schedule, whether that's every week or every month, whatever's reasonable, depending on how regularly you're updating those files. Downloading backups to someplace and identifying versions of your own. So maybe Office 365 does its default versioning all the time, but every month I also manually download a backup onto a USB drive just so that I know I have another separate archive. However it is that you decide to approach that, find something that works for you, but then do think about how you're going to be naming those files so that you can find them and understand the difference between those versions. We don't want to end up with that folder of final, actual final. I usually prefer putting the date at the front of my file, starting with the year, month, and day in that order, because then everything sorts into a chronological order, and I can immediately tell which end of the list is the newest version and the oldest version. We talked a little bit about this with file formats already, this idea of storing our data in open standard formats, things that will ensure more long-term readability. But in addition to the file formats themselves, we also want to think about the physical storage media where we may have them shared. So I'm assuming probably a lot of us don't burn things on CDs that much anymore. I think USB drives have kind of taken over. But if we're using physical media like CDs and DVDs, maybe you have older data from a previous project that's archived in some formats like that. You want to realize that those physical media degrade over time. So you need to be like copying and migrating to new media every 5 years or so, just to ensure that you're maintaining the integrity of those files. And the files themselves can become degraded or corrupt over time. And so there are some tools and processes for sort of checking the integrity of our stored files periodically and making sure that this file still is still structured the way it should be, is still stable. And I've provided another link here if you are interested at all in diving a little more deeply into that, into fixity checking in your digital files. But for the most part, the important part is, as agnostic a file format as we can get, open it semi-regularly and make sure if we need to that things get converted, and then making sure that we're using stable storage media. All right, access and sharing. So I sort of indicated this earlier. Some funders will have requirements for sharing data, at least at some level, or else providing a very strong justification for why there is absolutely nothing being produced that could be shared. So we may need to think about this more carefully if we have those kind of funder mandates. I think the first step is to look at everything that we said we're producing in that data description section and say, is there anything I can share? Any level of this, the most basic summary of what I've done, is there anything that would be appropriate to share? If you say no, okay, write out your justification as to why none of this could ever possibly be made available. If there's any bits of it that can be shared, then we start thinking through more specific decisions about, okay, which piece could I share? Where might I share that? What conditions or restrictions might I place on it? And so that's where then we'll get down to these more detailed questions of how and when might I plan on archiving or sharing particular pieces of this data, and really being able to explain why. Why is this the choice that I've made? Again, if we're thinking in context of writing a plan for a funding application, the funders are going to want to understand your thought process for why is this the piece of data that I can share? Why is this the best place and method for sharing it? And then explaining whether we have any particular terms of use, any particular conditions that might guide someone else being able to do something with our data. Okay, and then the last step here is thinking about archiving and preservation. So what procedures will you be used to ensure long-term preservation of our data? And we want to think about preservation even if we're not sharing it with other people, just for our own purposes if we may need to refer back to our data. Are we storing it on a local network drive, local computer drive, or a physical storage device? Are we storing it in the cloud? Are we depositing it in a dedicated data repository where it would be archived and preserved by some third-party entity that runs that repository? Are there any budgetary implications in what we need to do to prepare our data for preservation? So, maybe I'm planning on doing all of this myself at every step of my project. I'm going to create my data dictionary and create my code book, and I'm going to kind of manage all of this documentation as I go and make sure that by the end of my project, all my data should be ready for preservation. But sometimes maybe that's not really the way it works out. That's not efficient for us. Maybe we need to hire someone at the end to help create a full, robust set of documentation. Maybe the specific repository where it is the most appropriate place for us to archive this data, maybe that repository has a cost for depositing your data there. If we can kind of think through all of these decisions at the planning stage and have a sense of what we want to do, we can factor in those budgetary implications in the budget for our funding application. So your funding application itself could say, I'm going to use, $250 of my funding to pay for the deposit costs, to make sure that my data can be archived in the most appropriate location where it will be of the most value to my field, that kind of thing. So the more thought we put into the plan up front, the better then that we can plan that budget and not get to the end of a project and say, oh, darn, now they suddenly want me to do something and I don't know how to pay for it. And then kind of the last question that I always like to think about in this section is just thinking about the data that we collected, thinking about sort of the context and how we think it may be useful, to who it may be useful. Do we foresee a time when this data should eventually be deaccessioned or destroyed? So is there some date at which this is really no longer going to be informative, it's going to become obsolete, it should be taken down out of a repository at some point, or deleting the files? In some projects, that may not be relevant. It's just this data could be useful indefinitely, and I'll leave it indefinitely, and that's fine. We just want to understand our own context so that if that's relevant, then our plan should account for that, for saying this data would need to be deaccessioned or deleted after this date or this duration, and kind of be able to understand in our own mind why it is that it might become obsolete or dangerous after some certain period of time. Okay, so I want to talk a little bit about specific funder requirements. What I went through is sort of a very generic approach to a data management plan, but specific funders are going to be much more specific about the formats that they want to see. The screenshot that I've got here is an example of the NSF Bio DMP. So if you're applying for any kind of funding through NSF Bio, this is the description that they're going to give of what they want to see in a data management plan. So they outline these sections and then the questions and details that they want to see addressed in each section. It's going to be structured a little differently than the sections we looked at, but it's going to cover the same core questions about your plan. This is one of those instances, though, where it's just like we tell our students in class, read and follow the instructions. Very, very true in funding applications. If NSF Bio asks me to follow this structure, I want to be sure I follow this structure. I don't want to give them a reason to reject my application just because I couldn't follow their instructions. So I'm going to share with you a tool that can be super, super helpful if you're facing one of these specific funder templates for structuring your DMP, or really if you're creating any DMP, but particularly with a funder template. So this is called the DMP tool. It's just dmptool.org. You can use your SHSU email address to log in with your SHSU credentials. So you don't have to create a whole separate username and password to remember. We are institutional participants in this. This will give you access to an online system for creating a data management plan. It includes hundreds of templates for very specific funders and grant opportunities. And then it will guide you through the process of filling in each section, very similarly to what I've tried to do today, to kind of outline, here are some questions, here are examples, here are the things to think about. If you are working with co-researchers, the system supports collaboration, so you can all have access to a plan and be editing it and tweaking it and sharing feedback with one another. You also have an option to invite other people besides co-researchers to review your plan and provide feedback. So that might be a peer or a colleague who maybe has more experience applying for grants, or it might be the grant coordinator that you've been working with in ORSP, or it might be me as the librarian that you say, hey, I want to share my plan with this person so that they can read it and give me feedback before I finalize it. So these are kind of the advantages of things we can do in the DMP tool. And these are some screenshots. I stuck with that NSF Bio example here. So we create a project, give it some details about what our project is and who our collaborators are. But then the real meat and potatoes is this tab called Write Plan. This tab will be organized with the sections as this funder defined them. So it's going to lay out the sections that NSF Bio wants. It'll show me their instructions for what to include in that section. And then over on the right-hand side, I'll see this guidance pane. And I can get guidance from the DMP tool itself and then guidance directly from NSF to give me just a little bit more support, a little bit more of an idea of what to include here and how to approach this section. And it'll walk through with this kind of guidance through every section that I need to fill out. Then when you're done creating your data management plan in the DMP tool, you can output it as like a Word document or a PDF that then can just be interfiled with your funding application. All right, so wrapping up here, I've included a few additional resources in the slides, just in case they would be useful to you later. I manage a guide through our library for data management plans. There's several links in there that will let you look at example plans that other people have written, which I think can sometimes be one of the most helpful things. Is just, here's another plan in my field. What does it look like? as well as requirements for certain funders. And then a few other links here with, a framework for DMPs, step-by-step process with examples. And there's also this really great self-assessment tool. It's kind of a checklist that you can use after you've drafted a plan to help feel confident that you've addressed all the pieces that you should address. And then I've included a few things here at the bottom specifically about data sharing. So there's this tool called Sherpa Juliet that will let you look up a funder and understand what requirements they might have for sharing open data, if they have any. If you do need to share, there's some tools here for helping you to find the most appropriate repository where your data would best be housed. And then I've also got a link here very specifically for the NIH requirements. All NIH applications now require a data management and sharing plan, which is similar but a little bit unique in terms of DMPs. So if you're going to apply for NIH funding, I've included that there as its own resource. With that, I am going to say thank you. I know I dumped a ton of information on you, and I'm going to open it up for any questions you might like to ask.
Thank you. That's very helpful. Will you be sharing these slides as well?
Yes, definitely. You will get the slides right after the session, and then I'll share the recording as soon as it's completed in Zoom.
Wonderful.
Yeah. Any other questions? All right. Well, if questions come up later, by all means, please feel free to reach out and contact me. This is part of my job description. So you're not interrupting me. I'm always here and happy to give guidance or support on any of these kinds of issues. All right. Well, thank you all and have a great rest of your day.